rich, golden maple syrup on your breakfast table is made? Come on a journey from tree to bottle with us to discover the complicated process that underpins this natural delight. The journey starts late winter to early spring when maple trees are tapped to collect their sap. Healthy prospects are at least 30 to 40-year-old maple trees, typically sugar maples, with a minimum diameter of 12 inches. These trees may produce sap for decades, with each producing 10 to 20 gallons per year on average. To safeguard the tree's health, producers drill a little hole in it rather than creating large incisions. The spout creates a channel for sap to enter the hole. To increase efficiency, modern maple syrup production occasionally uses vacuum-assisted tubing systems. These devices gently use suction, increasing sap flow and reducing reliance on gravity. The network of tubing connects hundreds of trees and flows sap into a central collection tank. This strategy not only speeds up the harvesting process, but also decreases environmental impact and labor costs. Producers continuously monitor each tree to ensure that the taps do not jeopardize its ability to give sap in subsequent years, ensuring the sustainability of maple syrup production. Producers are pretty savvy about where and how they access trees in order to increase sap output while minimizing tree damage. Taps are placed in different locations on the tree trunk each season to allow previously tapped areas to heal completely. Furthermore, tree health is closely monitored to ensure that tapping does not inhibit long-term growth. Over the course of a season, a single tap can produce 5 to 15 gallons of sap on average. However, it takes around 40 gallons of sap to produce 1 gallon of maple syrup. This precise balance of consumption and preservation ensures a sustainable output for future generations. Sap flows from the trees and is gathered for processing as temperatures swing between freezing nights and thawing days. Freezing nights and milder days create a natural pressure system within the maple tree, causing sap flow. The tubing system, which is often found at the forest base, effectively transports sap from individual trees to centralized collecting tanks. Every collection location is designed to prevent contaminating exposure, ensuring that the sap remains fresh and pure. The collected sap is then pumped into larger storage tanks before being transported to the sugar house. Larger firms use refrigerated tankers to transport sap from the collection area to the processing plant. These transporters keep the sap at cool temperatures to prevent fermentation, which alters the taste. At this time, manufacturers frequently do preliminary tests on the sap to determine its Brix levels, that is, sugar content. More sugar means less boiling is required, which streamlines the process. Advanced monitoring systems provide real-time tracking of sap flow rates and amounts, allowing producers to optimize collection and transportation logistics. In addition to standard tube systems, many farmers are also using sophisticated vacuum-assisted collection systems to optimize sap flow. These devices create a moderate, consistent suction that increases sap collection efficiency, especially on days when the natural pressure changes are less helpful. Throughout the procedure, the sap is quality controlled. Sensors detect any pollutants or irregularities. Some manufacturers have even incorporated real-time tracking technology into their sugar concentration and sap volume update systems. This information ensures that only the highest quality sap makes it to the processing plant and allows for quick modifications. Many manufacturers use reverse osmosis systems to remove a good amount of water from the sap before boiling, thus boosting efficiency. Reverse osmosis technology works by driving sap through a semi-permeable membrane that separates water molecules from sugar and other components. This method can remove up to 75% of the water content, significantly reducing the necessary boiling sap volume. Higher sugar concentration in the concentrated sap that remains not only accelerates the boiling process, but also reduces energy consumption, which aligns with sustainable development principles. Large-scale farmers rely on industrial-grade reverse osmosis systems capable of processing thousands of gallons of sap daily. These machines provide maximum efficiency because they use sensors and computerized controls to monitor concentration levels constantly. To avoid further limit waste, the water extracted during this method is typically returned to the environment or recycled for use in cleaning instruments. Reverse osmosis enables manufacturers to maintain the high quality of standards of pure maple syrup while also increasing the overall sustainability of the production process. Many recent reverse osmosis systems are highly efficient because they include energy recovery components. These solutions reduce overall boiling fuel demand by up to 75%. Because some seasons produce sap with naturally higher sugar content, producers frequently alter the concentration obtained by reverse osmosis to match the specific properties of the sap collected. The water lost during this technique is used to maintain the sugar house or wash instruments, decreasing waste and promoting sustainable practices. This innovative approach has grown to be a cornerstone of environmentally responsible syrup production. Then it's boiled to lower its water content further. The concentrated sap becomes pure maple syrup. After being concentrated using reverse osmosis, the sap is transferred to large evaporators for boiling. These evaporators are designed to handle large sap volumes by using numerous pans to thicken the liquid as it flows through the system gradually. The boiling procedure necessitates precise heat management since temperatures above 219 degrees Fahrenheit, 104 degrees Celsius, produce the desired sugar concentration, roughly 66% bricks. The steam rising during this procedure, which frequently envelops the sugar house in a pleasant, earthy fragrance, is characteristic of traditional maple syrup production. Automated temperature monitors and hydrometers are used to determine when the syrup reaches the desired consistency, ensuring consistent results. During this stage, producers must be cautious since underboiling produces syrup that is too thin and prone to spoilage, while overboiling can result in crystallization or burnt tastes. Many modern buildings capture the steam generated during boiling and use it to heat the sugar house or fuel further production operations, increasing the operation's sustainability. Many modern sugar houses have automated evaporators that use computerized systems to regulate sap flow rates and heat levels, ensuring precise boiling conditions. While some producers employ oil or gas-fired systems to ensure consistent heat, others continue to use traditional wood-fired evaporators, which give the syrup a distinct smoky scent. Aside from consistency, the boiling process is regularly monitored for the final color and flavor profile of the syrup, which can be influenced by variables such as boiling time and seasoning. These factors contribute to the range of syrup flavors and grades that buyers value. The syrup is filtered to remove impurities after boiling, guaranteeing a smooth, premium product. The filtration process is responsible for removing sugar sand, also known as niter, that forms naturally while boiling. If not removed, these mineral deposits, primarily composed of calcium and magnesium, can give the syrup a gritty texture. Typically, producers can obtain clarity by pressing filters or gravity-fed filtration equipment. Food-grade filtering materials such as diatomaceous earth or paper filters are used to capture even the smallest particles without altering the taste of the syrup. eliminating any residual elements that could induce fermentation or deterioration extends the shelf life of the syrup. Larger businesses use automated filtering systems, which combine speed and accuracy to manage huge volumes properly. Following post-filtration, each batch is examined to ensure it meets the criteria for clarity and purity. The golden, translucent appearance of high-quality maple syrup is directly attributed to the meticulous filtration process. It is visually appealing and suited for grading. Some manufacturers use multi-stage filtration systems to achieve outstanding clarity and purity in their syrups. These systems often include pre-filters to remove larger particles, followed by small filters or Hoover filtration for tiny pollutants. Extra filtering processes can be utilized to provide a crystal clear appearance, which increases the visual appeal of premium-grade syrups. Along with removing sugar sand, the filtration procedure balances the syrup's consistency, ensuring a consistent pour every time. Maintaining strict filtration requirements enables companies to create syrup that not only tastes great, but also meets consumer expectations for quality. Every syrup batch is graded depending on color and taste to guarantee it satisfies consumer expectations and industry standards. There are 4 primary categories of maple syrup: very dark with a strong taste, amber with a rich taste, dark with a robust taste, and golden with a delicate taste. These classifications are defined by the syrup's light transmission, as measured using a spectrophotometer. Darker syrups with more assertive flavors are made later in the season, as the sap composition changes, whilst lighter syrups with delicate flavors are frequently made sooner. Beyond color, the syrup is thoroughly checked for consistency, sugar content, and flavor profile. Using hydrometers and refractometers, professionals ensure that the syrup has reached the required 66% sugar level on the Brick scale, which is critical for taste and preservation. Any batch that fails to meet expectations is either discarded or reconditioned. These tight grading and quality control systems ensure that only the best maple syrup reaches consumers, preserving the reputation and confidence associated with this natural product. Many manufacturers employ automated methods to precisely analyze syrup hue and light transmission, ensuring consistent grading throughout the firm. These technologies provide objectivity and uniformity, which complements traditional visual grading procedures. Another key component is flavor testing, which involves seasoned testers evaluating items for minor differences in sweetness, intensity, and even aftertaste. Syrups are microbiologically tested to ensure that they meet food safety standards for both domestic and international markets by being free of contaminants. These extensive checks serve to keep maple syrup's excellent natural product reputation. The final product is then packed into cans or bottles, ready to be enjoyed by consumers worldwide. Once tested and authorized, the syrup is transported to sterile bottling facilities. The syrup is usually packaged while still hot at 180 degrees Fahrenheit, 82 degrees Celsius, or higher to ensure sterility and create an airtight seal. This technique keeps the syrup fresh for an extended period of time, while also inhibiting bacterial growth. Packaging options vary according to the manufacturer, ranging from traditional glass bottles to more modern plastic containers, all designed to preserve and maintain the syrup's quality during storage and shipping. When the container is sealed, it is branded with the producer's logo, grade information, and nutritional statistics. Many companies now include QR tags so that customers can trace the syrup back to its source. The designated containers are then palletized for shipment and placed in cartons or cases. At this level, sustainability remains a primary issue. Many producers limit packaging waste by using recyclable materials. Before leaving the factory, each batch undergoes a final inspection to ensure that the syrup meets all quality and safety standards. In addition to traditional glass bottles, several firms are looking into inventive packaging options, such as biodegradable pouches or refillable containers to reduce their environmental impact. Custom-designed bottles for premium-grade syrups are visually appealing in high-end markets, as they frequently feature embossed logos or distinctive designs. Heat-sensitive seals are also used by producers to provide tamper evidence, reassuring customers about the safety of the product. To ensure durability throughout travel, each box is subjected to drop and pressure testing before being dispatched. These packaging changes not only protect the syrup, but also meet the growing customer demand for aesthetically beautiful and environmentally friendly products. From the golden syrup on your table to the soaring maple trees, the journey of maple syrup is a story of nature, history, and invention. The next time you pour maple syrup on your waffles or pancakes, remember the effort and care that goes into each drop. It is more than just a delectable garnish. It represents decades of tradition and a commitment to sustainable approaches. We appreciate you joining us for this behind-the-scenes tour of maple syrup production. Remember to like, subscribe, and click the bell for more fascinating analysis of your favorite foods. Enjoy the sweetness until next time.